Okay, let's talk a little bit about normal curve. The normal curve is the basis of everything you need to know in statistics because data tends to fall on a normal curve when you collect it. You tend to get the most common answers, the most common bits of data in the middle of the curve, hence why the middle of the curve is the highest point, right? It's the tallest because that's the most people in the middle. And you have infrequent answers and more unusual answers on the edges of the curve. And so you get the highest probability that any random person should end up, they're more likely to end up in the middle of that curve than on the edges of the curve. Right. So if you think of this as intelligence quotient scores, so IQ scores, you're more likely to be an average IQ score than to be brilliant Albert Einstein or to be somebody with an intellectual disability. You're most likely to be average or close to it. One of the cool things about the normal curve then is if you have a nice normal curve, then you can divide that bell curve up into sections. And those sections can be standard deviations. Typically, you'll have about 3 standard deviations, positive, 3 negative. So going towards the right, you have about 3 standard deviations before the bell curve starts to drop off and become non-existent. And you'll usually have about 3 to the left. So that'll be about 6 standard deviations altogether and a nice, normal, beautiful bell curve. You'll get about 99% of your participants in that nice curve. Characteristics of curves include whether or not they're skewed. When you look at this picture, you'll see in the middle there is a symmetrical distribution around that middle curve. That means that the left side and the right side of the curve, they're perfectly symmetrical. You take one and you flip it over on the other side and it's gonna come out looking exactly the same, right? It's not leaning at all. But when you look on the one side, you get the negative skewed, and then the other side, you get a positive skew. A little trick for figuring out whether you have a positive or negative skew, I call follow the tail. So if the tail of the curve, right, the longer tail of the curve is in the right direction, that's a positive skew. Just like you go positive on a number line, right, it becomes positive, and then the tail on a negative skew is on the left, the longer tail. And so you go on a number line, you go negative, right, when you're going to the left. So you'll get that negative. You can see here which is going to be higher and lower in terms of the mean, median, and mode. So that's kind of interesting information to pay attention to. But overall, the important thing is that skewed curves make statistics more difficult. This becomes one of the more important statistics to understand about your data before you analyze it, is if you have skewed data that's significantly skewed, that's meaningfully skewed, that hits a certain number on the measurement of skewness, then you are going to get some outcome of data that's going to be questionable. There are statistical ways to fix that problem. We'll cover that later in this course, but it's really important to understand the concept that skewed curves are a really important aspect of statistics. Finally, it's important to understand the kurtosis of a bell curve. So all bell curves also have a certain height to them, right? Are they tall, like a tall mountain, or are they flat, like just a small hill, right? And statisticians have given these names that you'll want to learn these names. So a nice middle curve is called mesokurtic, right? Meso means middle. And so a mesokurtic curve is great. That's kind of what you're looking for in statistics. A leptokurtic would be a very tall, right, with lots and lots of participants clumped up in the middle of the bell curve and very few people on the edges. Everybody's kind of scoring very similarly to each other in a leptokurtic curve. So that has a lot of implications, right? So if you have two curves and they're leptokurtic, they don't have to be very far apart for the two curves to be very different from each other, not have hardly any overlap in them when you have leptokurtic. So leptokurtic is an interesting dynamic. But if the data is that, then the data is just that. That's the way it is. And then finally, platycurtic is like a platypus bill. It's flat. And so platycurtic is going to be your more small hill of a curve. And for that, it's more difficult to find differences because people are spread out across the entire curve. You don't have a real lot of people in the middle. You have some in the middle, but then you have a lot of people sitting 1, 2, even 3 standard deviations away from the center. You still have a decent amount of people. So just kind of understanding how the kurtosis can affect whether or not you're able to predict things well with the data you have, because everything's built on probability. And if you have nice probabilities right in the middle, and lots of people in the middle, you're going to be able to predict things more easily with your data.
Finally, you may be wondering, can you get both skewness and kurtosis in the same bell curve? Why, yes. Yes, you can. You can have a bell curve that is skewed either to the left or the right? Positively or negatively skewed, and also be leptokurtic, mesokurtic, or platykurtic. And so you'll get numbers whenever you run your statistics, whether SPSS or another data program, that will tell you exactly how much skew you have and whether it's positive or negative, and how much kurtosis you have. We'll learn more about that in the SPSS portion of the lessons.